So hello and welcome back to the next video of this Engineering Mathematics 1 for Savitribai Phule Pune University. So in the previous video we have seen Lagrange's mean value theorem, and today in this video we are going to solve few numericals based on this Lagrange's mean value theorem. Mainly, you will get two types of questions based on the Lagrange's mean value theorem. The first type will be verify Lagrange's mean value theorem for some function f of x as it is given here, and the domain is given like from 2 to 4 here. So, and the second category we'll see in the latter part. So, let us see how to solve this kind of question. The first condition of the Lagrange's mean value theorem is the continuity. we have to check we have to check whether the given function is continuous within 2 comma 4 or not. So here, uh, to check this function f of x whether it is continuous or not, we have to check for what values of x the whole term inside this square root will become minus. And as you can see, this will become minus if the value of this x square, the value of x square is less than 4, and the value less than 4 is possible only if x is less than 2. So what I can say here is that if I put x equal to 2 here, I will get f of 2 is equal to square of 2 is 4 minus 4, so this will be equal to 0, and then f of 4 I will get square of 4 is what, 16 minus 4, and it is equal to how much, square root of, this is equal to square root of 12. So these two numbers I can check that we can see here that for 2 we are getting 0, for 4 we are getting square root of 12, which are both the valid numbers. But if I decrease this 2, if I decrease the value of x less than 2, let us say if I take 1, it is, so square of 1 is 1, and 1 minus 4 is minus 3, and you know that square root of minus 3 is not possible. It is a imaginary number. We are getting imaginary number there, so that is a discontinuous curve, we can say. So from that we can say that the f of x is continuous. F of x is continuous. It is a continuous function within 2 comma 4. Okay, so this is the first condition. Then the second condition is about the differentiability. So differentiability, to check the differentiability, first we have to take the derivative of this function f of x, and as you can see, f dash of x, that means derivative of this function f of x, can be obtained like this. You know that square root of something, whatever the function it is, square root of something can be differentiated as 1 upon 2 times root of the same function, that is x square minus 4, and then into what we are doing, we are differentiating whatever the term inside the square root. This is called chain rule. So here the derivative of x square will be 2x, and derivative of 4 will be 0. So this will be the complete derivative of f of x. And here again we have to check whether by putting sum of the value between 2 and 4, if I put these values, whether I am getting some indeterminate form or not. So this you can say, see that this is equal to x divided by root of x square minus 4. So here if I put the value of x as 2, again we are getting it is 0 here. If I put the value of x as 2, let us check it is f dash of 2, isn't it? F dash of 2 is what? 2 divided by square root of 4 minus 4 is 0. So root of 0 is 0, and this is a indeterminate form. And we can say we can check here that uh, if I increase this 2 value, if I increase the number more than 2, if I do it more than 2, what will happen here? The square of, let us say, 2.1, it will be more than 4, and will definitely get a positive number here, and it will have some value. And any number more than 2, if I take any number more than 2, I'll definitely get some answer here, and it will not be a indeterminate form. So from this, what we can say, that 2 or any number less than 2 will have no answer for this differentiation, isn't it? So what we can do here is, the differentiability condition is f dash of x must exist for the open interval 2 comma 4. That means we cannot consider 2 and 4. 2 and 4 is not to be considered, but any number between 2 and 4 is considered. So as you can see clearly, that for 2 it is indeterminate, but for any number greater than 2 it is not indeterminate form. So from this we can say that uh, the given function is differentiable as well as continuous. So from these two conditions, if these two conditions are satisfied, then as per Lagrange's mean value theorem, what as per Lagrange's mean value theorem, there must exist some c which belongs between a comma b, such that f dash of c is equal to f of b minus f of a divided by b minus a. So let us put all the values here. So from this problem we can see that this is what, this is your a, and this is what, this is your b. F of this, f of 2 is nothing but f of a, and f of b is nothing but f of 4. Okay, so all these values are already existing. Also f dash of x is existing here. So we will put all these values in this equation, and let us see what happens. So instead of x, if I replace with c, this f dash of c will become c divided by square root of c square minus 4, isn't it? See here, the f dash of x term, this x term is replaced with c. So here it will become c, here it will become c. As this is equal to f of b, you can check here, f of b is root of 12 minus f of a is 0, and divided by b is 4 and a is 2. Okay, so that way we will get this equation, and this can be written as root of 12 divided by 4 minus 2 is what, 2. And further simplification, let me do the square on both sides. If I do square on both sides, I will get c square divided by c square minus 4 is equal to 12 divided by square of 2 is 4. So from this, again I will simplify this. 4 3s are 12, and then I'll take this term on that side, so I'll get c square is equal to 3 times c square minus 12, isn't it? So this term, this whole denominator I'm taking on another side. Now further, if I simplify, c square I have to take it on that side, so I will get the, see here we have 3 c squares, here 1 c square, so 3 minus 1 is what, 2, so it is 2 c square minus 12 is equal to 0. See what I have done, I have taken this c square on another side, so here it will remain 0, and 3 c square minus c square will be 2 times c square. Then further this can be simplified as c square. Now if I take 2 common, I'll get c square minus 6, and it is equal to 0. Now if I take this 2 on this side, so finally I'll get c square minus 6 is equal to 0, and c will be root of 6. Because if I take minus 6 on another side, it will be plus 6, and if I take the square root, it will be root of 6. So if we try to find out the answer for this root of 6, what it will be? See, you can just compare the square of 2. Square of 2 is what? Square of 2 is 4, and square of 4 is 16. So whatever the square root of 6 is there, it must lie between 2 and 4, because the square of 2 is 4, and square of 4 is 16. So this number definitely must lie between uh, this a and b. So here we can write this definitely belongs to 2 comma 4, and hence the Lagrange's mean value theorem is verified, we can say. So this is another question of the same category. Uh, Verify Lagrange's mean value theorem for this function log x. F of x is log x, and the limit given here is 1 to e. Now to solve this, again we have to check the conditions. That is, first condition is about the continuity. So to check the continuity, we have to first of all check. So here you can see that this 1 is nothing but a, and e is nothing but b. So to check the continuity, first of all we'll put the value of a. So I will get f of a is equal to f of 1, and it is equal to log of 1, which clearly you can see log 1 is equal to 0. Then f of b is equal to f of e. Now b is our e, so it is equal to log of e, and the answer for this is 1. Log e is 1, we know that. So clearly we can say that for the boundary values we are getting a certain answers for this log term, but uh, and whatever the number, if I take whatever the number between 1 and e, there must be some answer to this f of x. Okay, because the log x is infinite, or it is indeterminate only when x is equal to 0. Okay, so it is definitely it is greater than 0. These two numbers are greater than 0, so that's why we can say that it is a continuous function. Then second condition is about the differentiability. So first of all we have to take the derivative of this f of x. F dash of x is equal to derivative of log x, we know that it is 1 upon x, and for whatever the value between this given domain 1 and e, whatever the value if I put here, I'll certainly get some answer. 1 upon 1 you can check, it is 1. 1 upon e is actually it is 1 upon 2.7 something. So definitely we'll get some answers, or any number between 1 and e, if I put it here, I'll definitely get the answer for this. So from this we can say that the given function is differentiable function. So for the in the exam you have to write these statements, that because of this is a differentiable, this is a continuous, like this. But as we have did this in the previous video, so in this video for in the previous problem we have done that. So in this problem we are doing the quick solution. So this is differentiable and it is continuous. So what we can say, as per Lagrange's mean value theorem, we must have some c belonging between a and b, such that f dash of c is equal to f of b minus f of a divided by b minus a. Now we have all the values. We have f of b, f of a, we have a, we have b, and we also have f dash of x. So putting together all these values, here the f dash of x is 1 upon x, so f dash of c will be 1 upon c, and it is equal to f of b, you can check it is 1, minus f of a is 0, and divided by b is what? B is e, and a is what? 1, so it is e minus 1. So from this, let us simplify this, and we can check that c will be equal to, I am taking c on another side, so it will be in the numerator, and e minus 1 I am taking on another side, so it is e minus 1. And 1 minus 0 is 1, so we should we have no need to count this. So this number, definitely you can see this number comes between 1 and e, because the value of e is 2 point something, 2.7 something, minus 1, it will be what? It will be like 1.7 something something. So this number you can check, it comes between 1 and e, and from this we can say that this c, that is equal to e minus 1, it belongs between a comma b, and hence the Lagrange's mean value theorem is verified. Okay, so thank you for watching this, and we will see the another kind of numericals in the next video, which are most probably asked in the exam. So stay tuned. Thank you. Please do like, share, and subscribe the videos for more updates.